This video will be looking at Chapter 8, Plane Geometry, and we're going to be specifically looking at triangles, regular hexagons, and irregular polygons. As far as the objectives, we looked in the last video of 8.3 at triangles, squares, rectangles, parallelograms, trapezoids, and so that objective pretty much has been covered. We will look at the use of the Pythagorean theorem in this section, and finding the area and perimeter of geometric figures and solving practical problems. So looking first at the Pythagorean theorem, it is a formula that helps us find the length of a missing side of a right triangle when we know the other two sides. And so importantly, we want to make sure that we have some vocabulary out of the way. Make sure to understand that when we talk about a side, we're talking about one length of a triangle that meets another length of a triangle at a right angle, and so it has to be a right angle. And then the opposite of that right angle is the hypotenuse. So if you're ever wondering what the hypotenuse is, just look at the opposite side of the triangle, and it is the line opposite of the 90 degree. Alright, so the Pythagorean theorem itself states that c squared, in this case the hypotenuse, or in all cases for when we're talking about c squared, equals a squared plus b squared. That is the Pythagorean theorem. And so we will be using that in different orders and different operations to be able to find out the side of the triangle. Well, let's go ahead and look at an example here. And we're going to use the Pythagorean theorem to find the distance for D, and this is D right here, and that is the hypotenuse of that triangle, the triangle that splits the rectangular field in half. And we're going to look at this and say, okay, if D is the hypotenuse and one side is 36 and the other side is 20, and those are in feet. So what we can do then is we have our formula, c squared equals a squared plus b squared, and that's what they're using right here. They've gone ahead and squared d, so d squared, substituted the 36 and the 20 for the lengths of the sides. When you calculate this out, 36 squared is 1,296, 20 squared is 400, and you get 1,696 when you add those up. And then we'll just go to the calculator, and I'd recommend using a calculator for these problems. 1,696, and find the square root. And the square root is going to be about 41. It will be about the square root, and notice that we're using it to the closest foot. So that was solving for the hypotenuse. Now if we want to solve for either one side or the other, and it doesn't really matter, you can call A or B either one when you're setting up these problems. But you do have to manipulate the formula a little bit, and so you can see that this is our original formula here. C squared equals a squared plus b squared is a Pythagorean theorem, and then we're able to convert it to this because of what they're doing here is they're go ahead and doing the square root. What you do to one side of the equal sign, you have to do to the other. And c is the result of c squared, and you have to go ahead and leave a squared plus b squared underneath the square root sign, since you can't get a perfect square from that. And then we can use that calculation in different forms to be able to move the variables around and subtracting from one side, which you do to the other, and you end up with either solving for A or being able to solve for B. And that's the formula that you can use for those. And again, most of the time it doesn't really matter if you just pick one of them, either solving for A or B, and then just label your variables accordingly. So these are the three different forms of the Pythagorean theorem. You might want to write these down on the side so that you can use them for different problems as you need either the hypotenuse or the sides. Let's go ahead and look at a problem then, and we're just going to go ahead and solve it. And I'd like you to take a minute and pause the video and try this one yourself. Okay, we're back, and so hopefully you were able to take this and rewrite the formula and then substitute in. And so in this case we're going to use x for our hypotenuse, and we are going to use 15 squared plus 8 squared. And we're going to be able to say, okay, 15 squared let's see, is 225. And 8 squared is 64. And 225 and 64 is 289. And so this is going to be everything squared here, because we are going to come down, and to be able to get this, we go ahead and square 289, or find the square root of 289. So x is 17. And so that is the way to solve that problem when you're looking for the hypotenuse. Let's go ahead and look at this in a when we're looking for a side. And again, go ahead and pause the video, and you can try this one yourself. Okay, so let's go ahead and take a look at this, and we're going to again rewrite the problem. A equals c squared. Oh. Minus b squared, and substituting this in, we're going to use y in place of side A, and c squared, which is our hypotenuse, is going to be 22.3 squared minus b squared, and we're going to use 13.8 for b for our side over here. So this is A, and we're using this for B when we're substituting in. And when we get this, we can look this up as 22.3 squared is square root of 497.29 minus excuse me, 13.8 squared is 190.44, and subtracting 497.29 minus 190.44, we get 300 and 6.85 squared, or the square root of, and so when we do that, we are able to get the square root of 306 is 17.5, and so we're going to go ahead and leave that at 17.5 and not take it out all the decimals because we're using that as our number that we're going out to, and so 17.5 is the answer for that. So hopefully everybody got that. So there are some special rules with some Pythagorean right angles using the Pythagorean theorem, and some of these you'll see especially in carpentry, and I included this slide because you'll see this often. This is what they call the 3, 4, 5. You can have this if you're trying to find square of a building. There's several different ways to be able to lay out a floor, to lay out a wall. The 3, 4, 5 is very useful. You lay out from one corner 3 feet, you lay out from the other corner 4 feet, and then you know that you're going to have 5 feet as your corners, and so that's going to be the 3, 4, 5, because 3 squared is 9, plus 4 squared is 16, and 5 squared, 5 squared is 25, and so that holds true. So that's called a 3, 4, 5 on a floor if you're trying to square a room. Now, using this for one last relevant problem, we're going to look at a mason using a ladder, and you'll see something like this on your homework. Go ahead and try this one on your own, and then we'll come back. Okay, all right. Hopefully everybody saw that they were able to lay the problem out using this formula here. And so, because we have the hypotenuse, but we're missing one side. If you didn't go this direction, or you needed a little help, so now you got the formula. Now go ahead and you can pause the video and try this one on your own. Okay, so let's go ahead and finish this problem out then and see what we've got. So we're going to substitute in here x for the missing a value, and our hypotenuse is 12 feet, and and minus, get some of these extraneous marks out of here. And so 12 feet squared minus 10 feet squared. And so 12 feet squared is going to be 144 minus 10 squared is 100, and so we have 44 under the square root. And the square root of 44 is 6.6. So x equals 6.6 feet. So when we come back up here to our problem, and 12 feet there, 10 feet here, and so this missing piece where the ladder leans up against the wall is 6 feet 6. Okay, and that concludes this video.